So welcome to part 2 of our series on vectors. So dun sa last video, in-introduce natin yung rectangular coordinate system. Now, we are now ready to define what we mean by a vector. So a vector is a quantity that has both magnitude and direction. Okay. So itong dalawang qualities na to, ito yung nagde-define sa isang vector. So one example of a vector is the displacement vector. So suppose you are in position A and then you traveled not necessarily in a straight line, but maybe like this, and this is your final position. Let's call this B. Now if we draw this arrow or directed line segment from your initial position to your final position, then we have a vector. So yung magnitude ng vector na to will be the distance that you traveled. So that will be the distance between A and B, not necessarily the actual distance that you covered to get from point A to B. So meron tayong magnitude, which is the distance from A to B, and then meron tayong direction. Okay? So why is this a vector? Well, meron siyang magnitude and direction in the first place. Okay? Now, if you started from A to B and then you walked to another point C, okay, pero yung distance from A to C is equal to the distance from A to B. So, halimbawa, ito yung nilakad mo. Okay. So, assuming na yung distance from B to A, distance from A to B is equal to the distance from A to C, then these two vectors will have the same magnitude, but they differ in direction. So therefore, they are different vectors. So another example of a vector is the force vector. So if you have an object, and for example, this is your object, which is a concrete block, for example, and then you're pulling it. Okay. So you are pulling it towards this direction, and the force that you use to pull this object will be the magnitude of that vector, and the direction in which you are pulling this object will be the direction of the vector. You can apply the same force. Example, you can pull it here using the same amount of force, so it will have the same magnitude. Okay. But since it is on a different direction, then this will be a different vector. Okay. So ito lang yung dalawang nagde-define sa isang vector, yung magnitude at yung direction. Okay. So this is an example of a wind vector map. Okay. So for some reason hindi kita yung source, ilalagay ko na lang dun sa description ng video yung source nitong map na to. But basically, in this map we have arrows that signify where the wind is blowing. So the longer the arrow, the stronger or the faster the wind is. And so actually ang nire-represent nitong mga vectors na to, for example, this arrow here is the velocity. And velocity is a quantity which is a vector. So it has both magnitude and direction. So the magnitude will be the speed of the wind. So how fast the wind is blowing. And then the direction will be, of course, kung saan papunta yung wind na yun. So those are examples of vectors. So how do we represent vectors? Okay. So we represent vectors by arrows. Okay. Sometimes we'll call them directed line segments. So they are line segments with an arrowhead at one end. So the direction of the arrow specifies the direction of the vector. So for example, itong vector from A to B, ito yung direction niya. The length of the arrow describes its magnitude. So whatever the length of this arrow is, of this line segment is, that will be the magnitude of the vector. So the vector represented by the directed line segment with initial point A and terminal point B is denoted by this. So in handwriting, we can write it this way, and or sometimes you can write it this way. So both are acceptable. So just be consistent with your choice of notation. Okay. Now, since all that defines a vector are magnitude and direction, if a directed line segment has the same direction and magnitude, then they will represent the same vector. So parallel directed line segments, for example, with the same direction, for example, this one, medyo hindi perfect yung drawing ko, but assume na parallel sila with this vector AB. And this one, and so if this has length C units, ito rin, length C units, ito rin, C units. These are different arrows in space. Kakaiba sila. But as a vector, they are the same. Dahil magkaparehas yung magnitude nila and yung direction. Okay. So how do we represent vectors mathematically? Okay. So in the previous slide, we have here three vectors which are identical, but they are represented in different ways. Okay. So again, they are identical because they have the same magnitude and direction. Okay. Now, we have a representation which is unique to any vector, and that is called the position representation of that vector. Okay. So the directed line segment having its initial position at the origin. Okay. Its terminal point at the point v1, v2, v3. Okay. That will be the position representation of that vector. So let me draw an example. So suppose ito yung x and y axis natin. And then I have a vector here. Okay. And I have a vector. Oops, but ganon? Ayaw. Let me erase this. Okay. And I have this vector and this vector. So they are the same vectors, okay, but represented by different directed line segments. Okay. Now the position representation of this vector will be the vector whose initial position is at the origin. So ito. Okay. So this vector now is and satisfies the description here. The initial position is at the origin and the terminal point is given by the point with coordinates v1, v2, v3. Okay. So kung yung initial position ng vector ay nasa origin at yung terminal position niya ay nasa v1, v2, v3, then we will call this vector, or we will denote this vector as the vector with components v1, v2, v3. Yan. Okay. So itong v1, v2, v3, these are the components of the vector. So some books will write v with a bold face. Ayan. and others will write it with an arrow on top. Okay. So, bahala kayo kung anong gusto nyo. Just be consistent with your notation. But for simplicity, we will just write the letter itself. And then we have triangular brackets on either side, and inside are the components of the vector. So this will be our notation for the position representation of that vector. Now, itong position representation, this is unique. Okay. So any other vector with the same components will represent the same vector. So sulat natin. So two vectors are equivalent, and if and only if they have identical components. Yeah. So for example, well, in this case, we have three components. So technically, itong vector na to dapat nasa three-dimensional space. Okay. So maybe you can have, although mahirap kasing i-visualize exactly kung saan naka-point ito. But even though I only drew two axes initially, yeah. This vector, dahil tatlo yung components niya, this is a vector in three-dimensional space. So I can define a vector in two-dimensional space. Let me call it W. Then its components will be just V1 or maybe W1, W1, and W2. So halimbawa nasa R2 ako. Ayan. So I'm in two dimensions. I only have the X and the Y axis. Then the vector W with components 1, 2 is represented by the directed line segment starting from the origin. Yan. And yung terminal point niya will be the point with coordinates 1, 2. So 1 and then 2. So this is now the vector W. Now we also have the zero vector. So the zero vector, 0. Okay. So in two dimensions, we have two components, both of which are 0. And in three dimensions, we have three components, all of which are 0. Okay. So ano yung magnitude ng zero vector? Well, it will be 0. So the initial point and the terminal points are the same, which is the origin. And you can think of that vector as pointing in any direction. Okay. So the zero vector is the only vector which you can consider as pointing in to any direction. And yung magnitude niya ay 0. So we will denote the zero vector by the bold-faced 0. And to distinguish that with the number 0. Okay, so we have a theorem here. So if the vector from P1 to P2 is a vector in 2 space, so nasa R2 tayo, the initial point has coordinates x1, y1, and the terminal point has coordinates x2, y2, then yung components ng vector from P1 to P2 will be x2 minus x1, y2 minus y1. Now, itong order ng subtraction natin, it matters. Okay? So, dapat mauuna yung mga components ng P2. Isusubtract natin siya dun sa mga components ito ng P1. Okay, medyo natabunan na. Sulat ko ulit. So, x2 minus x1 y2 minus y1. Okay. So analogously in 3 space or in R3, if I have the initial point as x1, y1, z1, and the terminal point as x2, y2, z2, then yung components ng vector from P1 to P2 will be x sub 2 minus x sub 1, y2, y sub 2 minus y sub 1, z sub 2 minus z sub 1. So let me just give a simple example in R2. Okay. Let me give an illustration in R2 since mahirap i-drawing yung nasa R3. Okay. Suppose ito yung P ko. It has coordinates. So P1, it has coordinates 1, 2. And then I have a vector, I have another point, which will be the terminal point. It has coordinates 1, 2, 3, 4, 5. Let me redraw everything. Hindi equal spaced yung mga tick marks ko. Okay. So let's start with, so I want P1 to have coordinates 1, 2, and I want P2 to have coordinates 5, 4. So yung P1, yung initial point, P2, yung gusto kong maging terminal point. So 1, 2, ito yung P1, and then 5, 4, 1, 2, 3, 4, 5, and then 1, 2, 3, 4. So ito yon, P2. And now according to this theorem, the vector from P1 to P2 will have components 5 minus 1, which is 4, and then 4 minus 2, which is 2. Okay. So i-drawing muna natin yung vector from P1 to P2. Ayan. So we know that this is not the only representation for this vector. Pero yung position representation niya will be the vector na nagsisimula sa origin. And that will be the vector with components 4 and 2. So nasan yun? 1, 2, 3, 4, and 2. 1, 2, 3, 4. So 2. This is the terminal point. This is the initial point. And if I connect the origin to this point, so again, itong point na to, it has coordinates 4, 2. And as you can see, they are identical vectors. Parallel sila and they have the same magnitude. Now, let's look at some examples. So find the components of the vector from 1, 3 to 4, negative 2. Okay. So madali lang yan. Let's just use the formula earlier. Vector from P1 to P2 will have components 4 minus 1, and then negative 2 minus 3. So this will be the vector with components 3, negative 5. And then for the other vector naman, so it's the vector from A with coordinates 0, negative 2, 5 to B with coordinates 3, 4, negative 1. So it will be the vector from A to B, and it will have components 0, minus 3, negative 2, minus 4, 5, minus negative 1. So we have negative 3, negative 6, and positive 6. So take note na yung vector from P1 to P2 is different from the vector from P2 to P1. It will have the same magnitude but it will have the opposite direction. Ganun din, the vector from A to B is different from the vector from B to A. So mangyayari, if we want to get the components of the vector from P2 to P1, magne-negative lang, i-apply lang natin yung multiply natin ng negative 1 yung mga components ng vector from P1 to P2, magiging siyang negative 3, 5. So, same thing with the vector from B to A. Yan. So, magiging siyang 3, 6, negative 6. Okay. Anyway, the problem is only asking for the vector from P1 to P2 and the vector from A to B. So, for illustration purposes lang itong dalawa pang vector na nandito. Now, let us formally define what we mean by the magnitude. So, the magnitude of a vector is the length of any of its representations. Now, if the vector is given by V, with components V1, V2, then the magnitude of V is denoted by this. This is identical to the absolute value function, or the absolute value symbol rather. But since hindi naman number ang vector, hindi siya number, so hindi absolute value yung ibig sabihin nito. Okay. So if we have two vertical lines and a vector inside it, it will denote the magnitude of the vector. So it is given by this formula. So the magnitude of V is equal to the square root of V1 squared plus V2 squared plus V3 squared. Okay. Now some books will call the magnitude as the norm, and it denotes the norm by this alternate notation. So instead of single vertical lines, double vertical lines. Okay. But I prefer this kasi mas simple itong notation na to. Okay. Now, why is this? Why does this expression give us the magnitude, or in other words, the length of the vector? So, tingnan natin. So, kung kung nasa 3-dimensional, I'm going to try to draw the x, y, and z axis. And then, ito yung terminal point ng vector natin. Since nasa position representation tayo, yung initial point natin ay origin, yung terminal point natin will be the point with coordinates v1, v2, v3. And then the length of the magnitude of the vector will just be the distance from the terminal point to the origin. But we know the distance formula, right? The distance formula is given by v1 minus the x-coordinate of the initial point, which is the origin, so 0 lang, squared, plus v2 minus 0 squared, plus v3 minus 0 squared. And that is exactly this expression. So, itong formula natin for the magnitude of the vector, galing lang siya sa distance formula na alam na natin.